Hi, welcome to this presentation called Getting Started with XCM, a top-down approach. I am Steve, Engineering Manager at Parity Technologies. And during this presentation, I will give you first a high-level overview of XCM, the technology. Then we'll go through some demos, some examples. The first one being an asset teleport, and the second one being a reserve-based transfer of assets. Finally, we'll be looking at the key learnings of what is XCM and of this presentation, and then what is basically coming in the next version of XCM. So first things first, XCM is a cross-consensus message format. So it is a language that aims to be generic and extensible that allows to communicate IDs between different consensus systems. Consensus system is a very generic word for blockchains. We want to build a very generic and forward compatible language. So we try to use as generic terms as possible. If you were to compare XCM to things like REST, then it is similar to the REST part of what we call RESTful services. So XCM is only the message format. It cannot actually send messages between different systems, right? And those messages are carrying meaningful content because they are to be interpreted and executed by the various consensus environment that will receive those messages. So really XCM is a message format for cross-chain transacting. Now you might also come across a term called XCMP, and XCMP is the transport protocol to transport XCM messages, all right? So, and this transport protocol is very low level, very message agnostic. It's only handling raw streams of bytes. So it is very important not to make a mistake when talking about XCM and XCMP because they're different basically. Now, talking about transport protocols, Polkadot implements several of them to transport XCM messages between different consensus environments. And we have two categories of message passing protocols. We have vertical message passing protocol that we abbreviate VMP. The first one being UMP. This is when a parachain connected to the Polkadot relay chain sends an XCM message upward. This is why it's called upward message passing, UMP. And on the contrary, when the relay chain, Polkadot or Kusama, sends an XCM message to one of the parachain, we're talking about downward message passing or DMP. So this is for the vertical message passing types of protocols. Now we also have horizontal message passing transport protocols. And by horizontal, we mean from one parachain to another parachain, right? So the first and most important transport protocol is XCMP, and it allows parachains to exchange messages with one another in a peer-to-peer manner. And obviously, one requirement is that those parachains have to be connected to the same relay chain. Now, this transport protocol is peer-to-peer, and it's still in the work while we are waiting for the finalization of and the deployment of this protocol. We have an intermediate implementation, or what we call a stopgap protocol, which is called HRMP, or horizontal relay routed message passing, which is basically transporting XCM messages via the relay chain from one parachain to another. This is not an optimal message passing protocol because we are passing all the message via the relay chain. But at least we have a solution while waiting for XCMP. And so HRMP will be deprecated when XCMP goes live. Now, XCM is a language, and we want it to be forward compatible and future proof, as well as extensible. So we need to have a well versioned language. So we have different versions of XCM. The initial versions were V0 and V1. They were not production ready, so we will not use them. The current version is version 2. It is live on Kusama and Polkadot, and on the Parachains that are connected to those relay chains. So this presentation uses XCM v2 mostly. And the upcoming XCM version is v3, and it adds some very interesting features for non-fungible assets, for better fee handling mechanism, additional transport protocols, or bridges. A quick interesting piece of information that we will need later when I show the demo is that you need to know that parachains that are connected to a relay chain are uniquely identified by their parachain ID. It's a number, and each parachain has its own identifier. You can easily find what is the ID of a parachain by looking at the parachain info palette. There is a function called parachain ID that you can query to know for sure what is the ID of a parachain. So in the context of this presentation, I use a local environment, and I have several chains. I will explain you what they are in a moment. But no, the state mine has ID 1000, Trappist 2000, and an additional parachain with ID 3000. A very important concept or language construct that we need in XCM is the ability to express location. And by location, I mean places to send XCM messages to, or that can receive XCM message or assets. And they have to be expressed in a way that is very general, very flexible, and also non-ambiguous. And those places can be a chain, can be a relay chain, a parachain, a foreign chain. It can be an account. It could be a smart contract. So you can imagine that to support that many types of location, we need like a very well-defined specification. And this is what we have with universal consensus location identifiers. When you think about locations in XCM, it's really like a file path in a file system. So they are hierarchical, and they're always related to a current location. So the place from which we are evaluating location. Some examples. First one is expressing or identifying a parachain starting from a specific location. So the two dots, I go one level up, and then I identify parachain 1000. So this means that I am identifying a sibling parachain from the perspective of an existing parachain. Similarly, I can identify an account. Then I use account ID 32, and then the 32-byte account identifier. I can also identify an account on a specific parachain, or I could also identify a pallet instance and an index within that pallet. A pallet is a module within a substrate-based chain runtime. Substrate is the open source SDK that Parity has created to build your own blockchain. Next to location, we also have assets. When sending useful XCM messages across different consensus environment, we also need a way to talk about assets. Assets are really important in the blockchain world. Digital assets can be either fungible, non-fungible, and potentially, who knows, in the future, even other types. Fungible assets are identified by a class and an amount. Non-fungible assets are identified by an ID and the asset instance. We also have like a very detailed specification for universal asset identifiers. So XCM has a lot of language constructs for locations, for assets, and also some type of instructions. And I will now show you a few demo, but first I said before that I was going to explain you that I'm using a local playground on my development machine that is composed of a relay chain called Rococo, and then 3 parachains that are connected to the Rococo relay chain. State mine is connected to Rococo. It is what we call a common good chain. Then we have Trappist. It is also a parachain. And then we have a third blank template parachains. Those lines here show that, well, the continuous lines are showing the relation that we have between the parachains and the relay chain. And then the dotted lines show the HRMP channels that were configured between the different parachains. So there's a little note here that normally HRMP channels are unidirectional. So if we want to have bidirectional communication between 2 parachains, then we have to set up 2 opposite HRMP channels. Now, why do we use 3 different parachains in this local environment? There's the relay chain, Rococo, and 2 parachains here. Rococo is what we call the community parachain testbed. So this is really like our test environments for testing parachain technologies in XCM. And as a relay chain, it provides shared security to all the connected parachains. It provides interoperability as well with the use of XCM messages and helping parachains to communicate with each other. It also has some built-in governance that we will not explore during this presentation. We have a parachain called StateMine. StateMine is what we call a common good parachain, and it is acting as a reserve for fungible and non-fungible assets. So it really is focused on the creation, the storage, and the operation of assets. So for both fungible and non-fungible assets. An interesting thing about StateMine, it is that it has a bit of a special relationship with Rococo, with the relay chain, because it relies on the governance body from Rococo, and it also using the same token as the relay chain. So it doesn't have its own token, it's using the same as the token from the relay chain. And therefore, it is trusted for a very special type of operation that we call asset teleports, which basically means that the user can send some fund of the native token from Rococo to an address that she controls on StateMine. And it is also it can also act as a reserve for other parachain, and I will explain that term reserve because there is this interesting type of operation in XCM that is called a reserve-based transfer. Finally, we have Trappist, which is a feature-rich parachain, so parachain with a lot of features, a lot of capabilities that we are using for exploring TM, for learning, and for testing all kind of things. Trappist also support assets, fungible, non-fungible. It also allows to deploy WebAssembly smart contracts using notably the Inc. Smart contract programming language that Parity is building. Trappist also has some light governance mechanism in its runtime, namely a council, but we will not explore that as part of this presentation, as well as some other interesting features for identity, for scheduling. Now, I will now show you how we perform um, an operation called asset teleport by teleporting native token from the relay chain, Rococo, to state mine. So what's going to happen is that I will um, send, use an instruction, an operation that will send an XCM message to Rococo, to state mine, and that will instruct uh, the XCM machinery, let's say, to teleport 1000 units of Alice's account on Rococo to Alice's account on StateMine, all right? Now, when we look at this, this is like the conceptual view of what we want to achieve, okay? But effectively, what's going to happen is that this operation will happen in, let's say, two phases. The first phase is that on Rococo, on the relay chain, the amount of native token that we want to teleport will be transferred from Alice's account to a special account called teleport checking account on the relay chain. That account is tracking the sum of all amounts that were teleported during teleport operations across all parachains. This is really just for, as the name implies, a checking account. Then the second phase on the receiving chain, which is state mine here, an equivalent amount of the token that we want to teleport is actually minted. So we cannot effectively you really pass tokens from one chain to another, right? So we have various operations that are happening locally in each consensus environment. So on the receiving chain, what happens is that when XCM has made sure that on the source chain, the amount that we want to teleport has been put in the checking account, then on the receiving chain, we have an amount that is minted directly into Alice's account, all right? Okay, so I'm going to show that to you now using Polkadot.js, which is the user interface, the web front end that we use for interacting with substrate-based chains. So you can see that I have 4 tabs in my browser here. The first one is the Rococo relay chain. The second one is state mine asset reserve chain. And then we have Trappist and an additional parachain. Let's call it parachain 3000. For this first example, I will not only use the two first ones. I will perform the asset teleport between the Rococo relay chain and the state mine parachain. So let's first look at the accounts. I can see that all the accounts here have 1 million, except the last one, have 1 million unit of native currency. On the receiving chain, on StateMine, most of the account have 1.7476 token, all right? So what I'm going to do is I'm going to transfer 1,000 amount of native token from the relay chain to the StateMine asset parachain. So for that, I will use an instruction, and to be a little bit faster, I've already encoded it. So I will just copy it here. This will be faster, and decode it. All right. So actually, to perform this teleport operation, what I'm doing is I'm using the limited teleport asset function from the XCM palette. XCM palette is a module from the runtime of the chain on the relay chain here. And this function allows me to teleport assets. The first part of the first argument that I have to provide here is the destination of the teleport operation. And in this case, you remember we've talked about locations in XCM. I have to pass a location that express or that identifies the destination parachain. So destination destination parachain here is state mine. So I am passing a multi-location that identify the parachain 1000. I don't have to go any level up because I'm already at the relay chain. And from a hierarchical point of view, when we express location in XCM, the relay chain is at the root, if you think about it as a kind of tree. So that is for the destination location. Then I have to specify who is which account is the beneficiary of the teleport operation. So for that, I also use another type of location, which is an account ID 32. What I'm going to do is that I'm going to copy Alice account address and paste it here, just to be sure it's the correct one. And very importantly here, the beneficiary account is expressed in the context of the destination that I previously specified. So I do not have to go any level up, and I am specifying the account of Alice on state mine. So this is correct. This is just the account that I have copied. All right. Now, the third argument I have to provide for this teleport asset operation is which asset I want to teleport, right? And to specify the asset, I'm basically teleporting the native token of the relay chain. For that, we use a special language construct. It's called a multi-asset, and I'm specifying that this is a concrete asset whose location is here. So I am sending the message from the relay chain. All right, I don't have to go any level up. And this is a fungible token. And then I have to specify what is the amount that I want to teleport. Now you can see that there's a lot of zero here. This is because the token, the native token of the chain here has 12 decimals. So if I count them, I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 decimals, and I have 1000 actual amounts that I want to teleport. Finally, the remaining arguments I have to pass are is an index to identify the asset in the multi-assets here collection. I only have one. This is the index of the asset that will be used to pay for operational and transaction fees during the execution of the XCM messages. Don't forget, we still have to pay for the infrastructure and to pay for the execution of those XCM messages. So we need to specify here which asset is used to pay for fees. And I'm using the native token of the relay chain. State mine is also using that same token. So this is going to be fine. It's this a small part of the amount that I'm transferring will be held for paying for fees. Finally, we have some weight limit, but we leave it to unlimited for now. So I'm going to submit this transaction with the limited teleport assets extrinsic from the relay chain to state mine. Now, it looks like things went well. So what I can have a look at is at the account balances. Indeed, I can see that Alice count was decremented by a certain number. It looks like it is correctly decremented by about 1000 units. I can look at the events that were generated here in the block explorer. So if I try to spot when the message was sent, I just found it here. I can find that some events were generated from the limited teleport assets call. And here I can find that 1000 unit of native token was withdrawn from Alice account. And the same amount was deposited in an account that we don't really know here, but told you which account that is. That is actually the teleport checking account. What I can do here is copy it, and I will add it to my address book here, right? I add it to the address book, and I know that this is the teleport check-in account, right? And I can see that it has 1,000 units. So that is what I was expecting. That account was just actually created. So that is the first part of the teleport operation. Now we need to look at state mine. This is the receiving, this is the right tab. This is the receiving chain. Well, I can already see that Alice's account was incremented by 1,000 token. So looks like the teleport operation went well. And if I look at the events, I can see that, well, I need to find the correct block. So this is the one. I can see that the second part of the XCM message was received on state mine, and an amount that is almost equals to 1,000 was deposited into Alice account, so was minted. And for the rest, some fees were paid. And it clearly shows that a downward message was processed. Remember DMP, because the message is coming from the relay chain to state mine. And yeah, so it looks like our asset teleport operation was processed successfully. Let's go back then to our slides. So this was asset teleport example using XCM from Rococo relay chain to the state mine parachain, right? So if I go back here, this is from a conceptual perspective, what we were trying to achieve. And effectively, this is what happened, where the amount was moved from Alice account on Rococo to the checking account. And on state mine, the equivalent amount minus fees was minted into Alice's account on state mine. All right. Now let's go to the next example, which is called the reserve-based transfer of asset. And this is a very interesting operation because it allows to move, from a conceptual perspective, a certain amount of a fungible asset between two parachains. What I'm going to demo here is a bit more advanced because we will talk about an asset called XUSD that I created already in advance on the state mine reserve chain. And this is a fictitious asset. So it's not a stable coin. I just created an asset, and I will manage the issuance of that asset for now manually. So what I've done is I created the asset, and I minted 1 million units into Alice's account on state mine. What I also did was to configure this asset on state mine as sufficient. And what that means is that any operation on that involve reserve transfer of that asset can only hold that asset only. Any accounts using a reserve transfer of that asset do not need to also have native tokens for fees. So actually, operational fees and transaction fees can be paid with that specific asset. So this is a very interesting capabilities that we have on state mine, where the community, using the governance mechanism of the chain, can vote to configure some assets as sufficient. Obviously, this is not going to be the case for all assets, but some very specific asset like stable coins, or maybe some others as well. If the community decide that they are self-sufficient, then every operation that involve them will not have to also involve native tokens. All right. And so that is the XUSD fungible asset that I have created on state mine. Now for reserve-based transfer, we also need to create derivative asset on the receiving chains that are involved in a reserve-based transfer. What I mean by a derivative asset is that in this case, the Trappist chain will have a local asset, a derived asset or derivative that is backed by the real asset that is actually being handled and managed on the reserve chain state mine, all right? And that derivative assets, the quantity, the issuance is absolutely managed by XCM. So we cannot mint some local amount of that asset because it has to be 100% backed by the asset that we have on the reserve chain, all right? So what I want to do here as part of this demo is to show you that Bob will have 1,000 units of XUSD on state mine, and I'm gonna reserve transfer a part of that amount to Trappist, where Bob initially does not have any XUSD. And as you may guess, like for the asset teleport operation, this is from a conceptual perspective what we want to achieve. Effectively, again, we have things that are a bit more complicated and that are happening in several phases. Firstly, the XUSD amount that we will transfer on state mine, that amount will be moved to a special account again that we call a sovereign account. And a sovereign account is representing the parachain. So every parachain can have a sovereign account on foreign chains. And this is used to track basically the amounts of tokens, funds that were transferred to that chain. So this is really like a reserve banking and how central banking is working, basically, but on chain and using XCM as a machinery, let's say. And in this case, I wanna show you how to use StateMine as a reserve. Now on the destination chain, again, once we have the amount that was transferred on sovereign accounts source chain, we have an equivalent amount of the derivative asset that will be minted into the receiving account. And that amount of derivative asset is fully backed by the real asset or also underlying that is held in reserve in the chain's sovereign account on state mine, right? That is a mouthful. So take a few seconds to, to let that sink in. But I will show it to you in action. So hopefully this would be a bit clear. All right, let's go for the demo now. So I'm not gonna need the tab for the relay chain anymore. So I'm gonna close it. Now I will go to the asset tab on StateMine, and I have my XUSD asset here. What I will first do is to mint 1 million of it into Alice's account, right? Wait a little bit. So I can see that Alice has 1 million XUSD. Alice is going to send 10,000 XUSD to Bob. All right. Right. Bob has now 10,000 XUSD on his account on StateMine. And so this is for the XUSD asset on StateMine. Now I want to look at the assets on Trappist, which is in the context of this demo, the receiving chain. And I can see that I have created a TX USD derived asset on Trappist, and there is currently no supply, no issuance for that asset. All right. So what I want to do is transfer, say, 5,000 XUSD from Bob's account on StateMine to Bob's account on Trappist, and it's going to be a reserve-based transfer, right? So 5,000 XUSD will be removed from Bob's account on StateMine and put in a sovereign account of Trappist StateMine. And then on Trappist, I will have 5,000 TXUSD of, this is the derivative asset that will be minted into Bob's account, all right? So again, I have my little cheat sheet, my operation that is pre-coded. So I'm going to use this to go a bit faster. This is Bob that's going to perform a reserve transfer. And I'm using here the limited reserve transfer asset extrinsic of the Polkadot XCM palette in the StateMine runtime. All right. So the arguments that I have to pass here are very similar to the ones that I passed for the asset teleport previously, right? But the difference is that I am not starting from the relay chain. I'm starting from StateMine, and I want to do a reserve-based transfer to a sibling parachain, which is Trappist. So when I will specify the destination, I have to go one level up. So I have to go back to the relay chain, and then I have to specify as uniquely identify the destination parachain, and Trappist has a parachain ID of 2000, right? So that's easy to understand. Secondly, I need to specify the receiving account on Trappist. So this is Bob's account. Specify that here. Again, as you remember, we specify the beneficiary in the context of the destination chain. So I'm not don't need to go any level up here when specifying the multi-location. Which asset is being transferred? So that is a bit of a complex one to understand at first. Is I'm not transferring the native token of the chain anymore. I'm transferring an asset that I defined in one of the module of the runtime of the chain here, and namely in this case the assets palette. Assets palette is a very fully featured module that we use from Substrate to create fungible asset, non-fungible assets. And it happens that when we add this module to the runtime of StateMine, that module has the index 50. So we need to identify very precisely which module we are referring to. And inside that module, we need to specify an index. And for the asset palette, this represents the asset that I created. I only created one asset, which is XUSD. So it has received the index 1. And then I specify how many amount of that asset that I want to transfer. I also, to make it easy, use 12 decimals for that asset. So I will transfer 5,000 XUSD from Bob's account on StateMine to the related account on Trappist. Because I have, prior to the demo, configured that asset to be self-sufficient, I can only just include that asset as part of the reserve-based transfer operation. I do not need to also include native token to pay for fees. So this XUSD asset will be used actually to pay for fees. And I don't set any limit in terms of weight. So I will submit the transaction. And if all goes well, we should have things move the way I explained it earlier with the slides. So we need to wait a little bit. All right. Now, what we can take a look at is at the events that were generated. looks like things went fine. I can see that 5,000 amount of an asset number one, was transferred from Bob's account to an account here that we don't really know, that was just created. So for sure, this is the Trappist sovereign account on StateMine. I will add it to my address book after. Yeah, and that's pretty much it basically. So if I add it to my address book here, this is Trappist. So I am on StateMine. This is Trappist chain's sovereign account on StateMine. Obviously, it doesn't have any native token, but because it's a sufficient asset, it doesn't need to have any native token. If I look at the balances, I can now see that Bob has 5,000 XUSD instead of 10,000. Just to be sure, I want to check the balance of the Trappist sovereign accounts. That's what I'm going to do here by directly querying the storage of the assets palette. And I can see that I have 5,000, all right? So things are correct on StateMine. If I go to Trappist, which is the receiving chain, I could look at the events that were generated from the XCM message that was received. And well, things are looking good. I can see that Bob's account was credited with almost 5,000 amount of asset number one here. Now, if I look at the balances of assets, well, and if I look at the balances, well, that's great. I have 5,000, almost 5,000, because these had to be paid, of the derivative assets that was minted to Bob's account. Great. So everything went fine. Going back to the slides and going back again to my conceptual view of the world. So I just did a reserve-based transfer from StateMine Bob's account to Bob's account on Trappist. Effectively, we have the operation occurring in two phases and involving sovereign accounts. So that was a rather simple reserve-based transfer because I did the work from StateMine to Trappist. Now I want to do an even more complex one that will start from Trappist because now I have some tokens, some of the derivative token on Trappist. And I want to do a reserve-based transfer from Trappist to the Parachain 3000. And again, using StateMine as a reserve. So on the destination parachain, I have created again a derivative asset called PXUSD, fully backed by the real asset on StateMine. No amount has been minted. And effectively, what's going to happen now is that there will be a movement between two sovereign accounts of StateMine, right? I hope that does start to make sense. Effectively, what happens is the amount of token is burned from the source account on Trappist. We have a movement of fund between two sovereign accounts on StateMine. And then on the receiving chain, we have a derivative asset that is minted into the destination account. All right, let's see that in action. Again, I have my little cheat sheet here because this is actually a very complex operation. I will start now from Trappist because this is what I want to work with. And Bob is performing this operation. Now, I don't have to do this full reserve-based transfer between two parachain. We don't have any handy method or extrinsic on an existing module, so we actually have to encode a fully detailed, let's say, XCM message, and an XCM message can be composed of many intermediate instructions. This is where you can see that it's a very rich language. For will not go through all of these in very much details, but you can see that first on the source chain, we have to withdraw the asset and we have to specify which one. And the asset is actually the real asset on state mine, not the local derivative one. I'm going to transfer 1,000 of it. Then when we are, when the instruction onto the phase is at the state mine level, let's say we have to initiate a reserved withdraw, and that is involving sovereign accounts. We have to buy for execution time and specify with which asset we pay for that. We have to deposit our reserve assets. And then finally, the last operation, the last hop, which is on the receiving chain, we are depositing an asset on the receiving account. Just want to make sure that is the correct one. So I'm going to copy Bob's account here. All right. Now let's do this. I'm executing this instruction. So if all goes well, I should see 1,000 amount of the XUSD derivative asset be removed here from Bob's account. All right. Takes a little bit of time, of course, because it involves communication between multiple chains, but it looks like things went well. Bob's account was decremented by 1,000 TXUSD. All right. Sorry, little problem with my headphones. So just to repeat, we have Bob's account on Trappist, who was decremented by 1,000 TXUSD. Now, if we look at state mine, we should see a movement of token between two sovereign accounts. I can see that a new account was created here that we didn't know of. I can see that 1,000 token were burned, in this case, from the Trappist sovereign account, and 1,000 or a bit less because there were fees were minted into this new account. And well, you can guess this new account is the sovereign account for Parachain 3000. That's the name. Obviously, again, there is no native token on that account, so I have to go check the state in the assets palette. Trappist has 4,000 and Parachain 3000 has a little bit less than 1,000. So that is correct. Now, final piece of the show is on the receiving Parachain 3000. I can see that an XCM message was received. Oh, sorry, that's a previous block. An XCM message was received and a little bit less than 1,000 of local derivative asset was minted into Bob's account. Let's verify that now. This is the PXUSD. I'm on the destination chain. Bob's account was credited with almost 1,000 amount of the PXUSD derivative asset that is fully backed by the asset, the XUSD asset that is on state mine, and that is held in reserve in sovereign accounts. So that was the last example about reserve-based transfer that basically show you already quite, let's say, the power and the flexibility of XCM to perform operations across different chains and using meaningful messages and instruction like asset teleports, asset reserve-based transfers. So yeah, so I think that that's really amazing. I hope you enjoyed it. Quick recap, XCM is a cross-consensus message format. We've seen that Polkadot implements several message transport protocols. Remember, we have vertical message passing, horizontal message passing. XCM is a generic, extensible, future-proof, and forward-compatible language. Current version that we're using on Polkadot and Kusama is version 2. We have a very rich set of instructions and primitive for asset locations, accounts, fee handling, and the like. XCM support asset teleports to move an asset from one chain to another, and reserve-based transfer to perform operation that use a chain as a reserve for other chain to perform fully backed derivative asset movements. That was a mouthful again. So yeah, conclusion, XCM is amazing. I hope you enjoyed it, and it gives you the motivation to try it out for yourself. Just know that we have some super exciting things coming in the next version of XCM, XCM v3, with full support for non-fungible tokens, NFT, better mechanism for fee handling. We'll also be able to send XCM messages across bridges to and from foreign consensus environments. And also, we start to enable the smart contract layer. So smart contracts can send and receive XCM messages. And so we can express operations to be performed across different consensus environment, including layer 2s, so smart contracts. Great. I hope you enjoyed this presentation and you've learned a lot about XCM and you've enjoyed the demo and you will want to try them for yourself. See you.